When you need to pump up those tunes, the traditional way of turning up the volume can be a real inconvenience. A good party always needs louder music, but how can you even tell how to adjust the volume anymore? The cryptic buttons are confusing and can really ruin your vibes. Adjusting the volume is lame and makes you look stupid, not to mention how stinky it is.
Introducing the pulse rate controlled volume controller. That's right, now you can control the volume using your pulse rate with the pulse rate controlled volume controller. Just 4 easy payments of $4.99.
Hey, what do you think of the name?
Did you even try? It's a terrible name.
Introducing the finger-mounted pulsimeter variable auditory amplifier and deamplifier, or FIMVAD, or something. Just 4 easy payments of $4.99. Making a mess is a thing of the past. When you want to pump those jams, don't press a button, just pump that heart. Do some squats and the volume will go up.
Need to adjust the volume, but no time to figure out what the plus or minus buttons do? Not to worry. Bust out your sexiest workout and the volume will increase with your heart rate.
Traditional ways to adjust the volume are disgusting. Throw it away. With the finger-mounted pulsimeter variable auditory amplifier and deamplifier, you will look good and your music will sound even better. Now, if you're curious how the finger-mounted pulsimeter variable auditory amplifier and deamplifier actually works, stay tuned for an explanation of how this carefully engineered device was made. So, much like the quality of this video, the quality of the device is just as bad. So to start it off, we can look at the sweet carrying case that it comes with, which is a shopping bag. I did have a 3D printed case for it, but it didn't work out and I didn't want to print another one. So we got this. So the actual device is made up of a cheap Chinese pulse sensor, which is hooked up to a breadboard that feeds into a cheap Chinese knockoff Arduino. And the Chinese knockoff Arduino runs code that translates the analog output of the sensor into actual pulses. This is literally all the code on the Arduino, and I don't even think I wrote most of it. And the pulses get sent over to a Raspberry Pi that calculates the beats per minute. And the Pi is running code that sends the beats per minute to an app on my Android phone. This is the Pi's code, and I did write all of it, and it is all awful. And the Android app then uses the beats per minute value to update the volume. The Android code is pretty simple, and the app is pretty dumb looking, but it works. It's quality. I wanted to get my heart rate up to do a little demo of this thing, and I thought the easiest way would be to go to my apartment's gym and literally sprint half a mile. And I thought wearing jeans would get my heart rate up faster or something. I don't think it helped. It just sucked a lot more. But my heart rate did go up, and so now we can go into a demo. So on the left is the output of the Raspberry Pi. You'll see it prints every time a heartbeat is detected, and then every 5 seconds it'll calculate a new beats per minute. On the right is just me awkwardly standing there because I didn't know what to do. I'm sorry. You'll notice that anytime the BPM number goes up, the music gets louder, and anytime it goes down, the music gets quieter. You'll also notice that consistency isn't really a thing with this, and that's mainly because the pulse sensor I got was, I think, $11, and it doesn't really work that well. But yeah, I was jamming to royalty-free music all night. It was a blast, man. Just look how much fun I'm having. And I'm sure you're asking yourself, is it really convenient to go sprint half a mile whenever I want my music to be louder? And I honestly think the answer is always yes. Yes, it is.